For my first hypothesis, I wanted to test whether more than 18% of the cars at the Ontario Airport lot are black. I used a systematic sample mainly because it was easier to use with that picture. I stated my null hypothesis and my alternative hypothesis. I identified my sample size and defined my variable. The first method we're going to use is p-value. I calculated my p-value by dividing the number of black cars by the total number of cars, which gave me a p-hat of 0.347. Standard error, I'm gonna use the formula for standard error. Plugging in the values, I got a standard error of 0.0452. For the C-score, I subtracted the hypothesis proportion from p-hat and divided it by the standard error. This gave me a C-score of 3.69. For the last step, I'm going to use the calculator function normal CDF. We're going to put down the inputs. Our lower value is 3.69, upper is 999, our mu is 0, and our population standard deviation is 1. When it calculates, it gives a scientific notation. That's the whole answer the calculator gave me, but that is super easy to fix. We're gonna move our decimal point from the left since it gave us a negative notation. Our final answer is 0.0001. On the second method, it's gonna be critical value. Our tail is a right tail test. We got our C-score from earlier, it's 3.69. And I get the area from alpha, which is 0.05. I'm gonna input that in IbNorm. It's gonna calculate 1.64. Since the test statistic is greater than the critical value, this once again confirms that I reject the null hypothesis. For the confidence interval method, I use a 95 confidence level, which corresponds to the critical value of 1.96. Using p-hat and q-hat from earlier and the sample size, then it will be put in the margin of error formula along with the critical value. The total is 0.013. I then created the confidence interval by subtracting and adding the margin of error to p-hat. Since the hypothesis proportion of 0.18 does not fall within this interval, means we reject the null hypothesis too. For my second hypothesis, I wanted to test whether the mean height of women is less than 6-7 inches, and I generated a list for it. I wrote down my null and my alternative hypothesis along with the sample size, sample mean, and sample standard deviation. First method is p-value. Since the population standard deviation is unknown, use the calculation function t-test to find the test statistic. I subtracted the hypothesis mean from the sample mean and divided by the standard deviation over the square root of the sample size. This resulted in a test statistic of negative 3.14. For the second one, we're going to use the calculation function TCDF. This is a left-tailed test, so we're going to shade them from the left. Our lower bound is negative 999, our upper is negative 3.14, and our DF is 49. The TCDF function will calculate that and we'll get a total of 0.0014. Since the p-value is less than 0.05, we reject the null hypothesis. For the second method is critical value. The statistic from earlier is negative 3.14. The calculation function I'm going to be using for this one is MBT. The area is 0.005 and the DF is 49. This is a left tail test, so we're going to shade them from the left. Once we put that in the MBT function, we get negative 1.677. Because my test statistic is less than the critical value, this again confirms rejection of the null hypothesis. For the last method is confidence interval. Using t-interval for this one, The inputs for it is sample mean, sample standard deviation, sample size, and the confidence interval. The interval will give up 64.9 and 66.5. Since the hypothesis mean of 6 to 7 inches does not fall within this interval, this final method also supports rejecting the null hypothesis.